Hi everybody. So in this video, I'm going to show you how to derive a mathematical proof. We'll work through question 1 and question 2, and then we'll try an exam style question at the end. If you want to work along with me, I'll leave a link to the PDF in the description below. So for example 1, we've been asked to prove that 2n plus 3 all squared minus 2n minus 3 all squared is a multiple of 8 for all positive integer values of n. Okay, so the first thing that we need to do is we need to expand out these two brackets, this one and this one. So we'll write 2n plus 3 multiplied by 2n plus 3. This is the 2n plus 3 squared minus the 2n minus 3 squared. And then we'll expand out each of these pairs. So we'll have 2n times a 2n. This will give us 4n squared. We'll have a 2n times the 3, so 6n. 3 times the 2n, which is another 6n. And then a 3 times a 3, which will give us 9. Then from this, we'll take away the 2n times the 2n, 4n squared. It's really important that we have this bit in brackets, so we don't forget to expand out the negative later on. Then we'll have the 2n times the negative 3, so minus 6n. And again. And then the negative 3 times the negative 3, which will give us positive 9. We can collect the like terms. So we've got 4n squared plus the 12n plus the 9 minus, this will give us negative 12n, and then we'll expand out the negative, so we've got negative 4n squared. This negative times that negative will give us a positive 12n, and then the negative times the 9 will give us negative 9. So now if we continue collecting the like terms, we've got a 4n squared, we'll cancel with a negative 4n squared to make 0. The 12n plus the 12n, this will give us 24n, and then we've got a positive 9, take away the 9, and this will give us 0. So they will cancel. Then we're asked to prove that this is a multiple of 8. So we need to factor out the 8, and this will give us 8 lots of 3n. The 8 times the 3 will give us a 24. So we can say, therefore, we have proven that 2n plus 3 squared minus 2n minus 3 squared is a multiple of 8. It's really important when you do have a mathematical proof to include a written statement at the end. Okay? So perhaps you want to try question B yourself. So if we begin, we've got n squared minus the 2, and then we can expand out in these brackets, but we need to keep the negative on the outside. So negative n minus 2, and then another n minus 2. So now we've got n squared minus 2 minus, and what did you get when you expanded these brackets out? Well, we get the n squared minus the 2n minus another 2n, so minus 4n, and then the negative 2 times this negative 2 will give us positive 4. And what do you think we should do next? So n squared minus 2 minus the n squared, we're multiplying out this negative now. Negative times the negative 4 will give us positive 4n, and then the negative times the positive 4 will give us minus 4. And then we can see this positive n squared will cancel with this negative n squared. And then we've got the negative 2, take away the 4, will give us negative 6, and this 4n. So 4n minus 6. And because we're asked to show it's an even number, we need to show it's a multiple of 2. Well, we can factor out a 2, and we'll get 2 lots of n minus 3. So our written statement would be, therefore, it is proven that n squared minus 2 minus n minus 2 squared is even. Okay, let's try example 2. So we've been asked to prove that the difference between, so this difference is important, two consecutive square numbers is always odd. So we know difference means subtraction, and we want two consecutive square numbers. So the first number would be n. The number after this, if it's consecutive, would be n plus 1. So for instance, if you've got 3, the next number would be 4 because you're adding 1 to it. This is what makes them consecutive, the addition of 1. Now we're squaring these numbers. We want the consecutive square numbers. So we square each of these. And because we want the difference, we need to have a bigger number first. So n plus 1 squared minus the n squared. So we've got the difference between two consecutive numbers. So what do you think we need to do next? So now we need to expand out this bracket. We've got n plus 1 multiplied by itself minus the n squared. We can expand out this bracket. We've got the n squared plus the n plus another n and then plus 1 minus n squared. Do you think we can tidy this up? Yeah, we can collect the n squared terms. These will cancel to make 0. So we've got 2n plus 1. And how do you think we're showing this as an odd number? This is what we were asked to show. Well, 2n is a multiple of 2, so therefore it must be even. And the number after an even, this addition of 1, must always be an odd number. So our statement will be, therefore, the difference between two consecutive square numbers must always be odd. Okay? Let's try an exam style question. Okay, so in this question, we've been asked to prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. So we know the difference will be a subtraction, and we want the squares of any two consecutive odd numbers. So we need an odd number. Now we know an odd always follows an even, and we can get an even by multiplying something by 2. So this will always be even. What we couldn't say is n is odd, because n could be any number, odd or even. But when you double it, you always get even. So we've got the even. If we add 1, this will always be odd. So this is our first odd number. The next odd number, well, if you've got 1 and you add 2 to it, you'll get the next odd. So we need to add 2 to this term. When you add 2 to it, we get 2n plus 3. Okay? So these are our two consecutive odd numbers. Now we want the difference between the squares. So if we look at the bigger one, we've got 2n plus 3 squared minus the 2n plus 1 squared. So now we've got the difference between two consecutive odds. We'll expand out each bracket. So 2n plus 3 multiplied by itself minus 2n plus 1 multiplied by itself. we'll get the 4n squared plus the 6n plus another 6n, and then 3 times 3 is 9, minus 2n times 2n, so 4n squared. Then we've got 2n plus another 2n, and then we've got 1 times 1. So what do you think we need to do next? So we've got 4n squared plus 12n plus 9, and then we need to expand out this negative. So we've got negative 4n squared minus the 4n minus the 1. And now we can collect the like terms. 4n squared take away itself will go. Then we've got the 12n take away 4n. This will give us 8n. And then the 9 take away 1 will give us 8. We were asked to show it's always a multiple of 8, so we need to factor out this 8. And we get 8 lots of n plus 1. And because we're multiplying something by 8, this is by definition a multiple of 8. So therefore, 2n plus 3 squared minus 2n plus 1 squared must be a multiple of 8. Okay, well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.